Welcome to this infrastructure domain session as part of the buildingSMART International Standards Summit here in Valencia 2024. Thank you for joining us today. My name is John Proctor and I am your moderator. Details of today's session are on the screen. We will be hearing from the IFC for Tunneling project team, Michel Rives, the project leader, will start the presentation and will then pass to Andre and other members of the team. The session is scheduled to last 90 minutes, including time for questions as we go through or at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand to Michel, I'd like to remind you that this is a hybrid event. If you're online, your microphones will remain muted. And if you wish to make a comment or ask a question, please use the chat box and I will prompt you to do so. For attendees here in the room, welcome. Please keep background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and we'll use the microphone that Michel is currently holding. I also need to bring to your attention the following information. buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that are developed do not favour any particular provider but are open, non-binding and accessible to all. Please take note of our antitrust code of conduct. With that, I will pass to you, Michel.
Okay, thanks, John. So let's get started. My name is Michel Rives. I'm the honored lead of this terrific team that has been developing the content of this IFC for tunneling and geotechnics extensions. We started 3.5 years ago. I ran a consulting company that does BIM management on a variety of infrastructure projects, roadways, railways, metro, in Europe and Africa, and some business in the US as well for data centers and for Meta, Facebook. And I'd just like to have Andre introduce himself.
Yeah, my name is Andre Borrmann. I'm heading the chair of computational modeling and simulation at the Technical University of Munich, and I'm acting here as the technical lead in this project, which is a big pleasure.
So let me start by asking you a question. What it is that you're expecting from this one session? Okay, limited expectations. That is good. That is good because I think we can exceed these expectations, actually, as a matter of fact. That's an easy exercise for us. We have a lot of material to share with you, a few slides, of course, but then the second part will be including some live presentations as well. And because we are at the sort of the last phase of our project, whereby we've been developing, as I said, extensions for IFC to cover tunneling and geotechnics, we will be presenting as well a set of examples of IFC exchange files that contain indeed earlier versions of those concepts implemented by some software vendors. The collaboration with software vendors has been key all along that project, and we are very happy to start being in a capacity to show you some of those examples that have been created by these software vendors. Some in a room. I need to push the button. Okay, thanks. Right, so the agenda for today, basically an update on where we stand in terms of the deployment, meaning the integration by software vendors of those concepts that we've been developing. A word on the collaboration that we have been having with OGC. That has been as well something key in the project itself to make sure that we were co-developing concepts with OGC, specifically when it comes to geotechnics. That's a subject that has been touched yesterday morning and this morning as well, what it is that BIM and GIS have in common. This one subject matter, subsoil modelization, subsoil knowledge or lack thereof, that has been something that we, from the ground up, decided to develop in common with OGC. So we have a common conceptual model for geotechnics. And then the deliverables that we are to produce so that the outcome of our project gets into the publication process for ISO. Thanks, Andre. So nice of you. So I was talking about a terrific team. So, you know, some of the teams, project teams, typically would meet in a bar. They would discuss about, you know, potential concepts, future ideas in a bar. We discussed in tunnels. So this took place in Oslo at the previous BSI conference. So that people, you know, can understand exactly what is the implication of what it is that we are developing. So it's really to help design, but it's to help construction. It's to help with as-built recollection, and to some extent, it is meant to help as well with transferring over information to GIS, transferring over information to assets management. So we have all those concerns in mind when we started the project. Okay, you're getting lazy now. You've seen that before, but so we extend the 4.3 schema with specifics for describing what the tunneling structures are about. So that's one addition. But the other addition is this one thing here that is much more transversal and that describes what the subsoil conditions are. And this serves, of course, underground structures, but it serves as well bridges, it serves as well buildings when it comes to deep foundation. So all that part that we are adding to the IFC schema will serve those different domains. And I think that is rather key and to the benefit of several project teams and domain rooms. And of course, at the end, we enrich the ISO schema. Thank you very much, Andre. The way, so some of you know of this, but just to make sure that the entire room is up to speed, the way we decided to structure the project as well was to make sure that we had representatives from different profiles of stakeholders, meaning designers, so basically geotech engineering bureaus, civil engineering bureaus, owners, infrastructure operators, national bodies, would typically be prescriptive as to how to use BIM and how to use open BIM in the context of those projects. And a set of research bodies, including the Technical University Munich, the Borrmann University, the University of Florida, University of Leoben in Austria, and in Sao Paulo in Brazil. And those experts, we group them into 3 domain teams. So we have 3 teams of domain experts, more or less 55 people or so, and one team of IFC experts. And basically, this team that Andre is leading is the one that is presenting to you today. So that's only a small set of 55 people I was referring to. Right, so I talked about the coordination with OGC, but next to it, we had as well started from the ground up collaborating with ITA. ITA is the International Tunneling Association. It's a very well-structured organization, international one, with a set of local branches everywhere in the world, very active. And in their view, this is one of their slides, a tunneling design construction process is made of several pieces, including a central one that is IFC for tunneling. So they've recognized the value of promoting a standard, an open standard, and a norm, an ISO norm at the end, so to make sure that the exchange of information in between the different actors is actually properly structured and semantically rich. So that's a major, for them, from their perspective, as end users, this is a major step forward, and frankly, they promote it, and they will then, and they do disseminate the information within every single country in the world. So that's key. Just to give you a sense of what they do, they basically express user expectations, they communicate upon best practices, they communicate upon examples, and this is the information that they circulate within their affiliates. One of the examples that we've been working on is the case of a tunnel for the French Ministry of Transportation, whereby the idea was to identify the value add of a BIM approach in the case of the design of a new tunnel, as well as in the situation of a tunnel that was already under operation. So from their perspective, from their users' perspective, operators' perspective, they assessed what was the value add of an open beam approach. And that, of course, is key because then we can start to circulate that information to the entire industry. In addition to that, they produced recommendations. And the reason why I'm stressing this out is because in these international guides here, guidelines here, or in the German one or in the French one, to give a few examples, they really refer to IFC for tunneling and what the value is for these. So those documents we do not produce, they produce. And of course, it is engaging us clearly with the responsibility to deliver upon that expectation. So let's jump a little bit into the scope itself. So now, we are, as you've understood, we have three main areas that we are covering: geotechniques, structures, underground structures, and systems. The systems that allow to operate an underground facility, an underground tunnel, or an underground space. To start with, as far as geotechnics, what we did was first an analysis of what was existing today in terms of what OGC was covering in terms of geology, and what was BSI covering in terms of geology as well. Because we identified quite quickly that everything that relates to geotechnics when it comes to the construction of an underground structure was not really properly covered. So we ended up with basically stating that we needed to be developing those concepts, those object classes, to describe how a subsoil configuration can be specified, and whether, again, one knows or doesn't know well of what the underground situation is about. Because typically you would make an assessment before you start to excavate, and then you would face the real situation whilst you are excavating, and then you need to be documenting what you have been facing and what you have been reinforcing, for example. And that documentation has to come back at the end in the as-built, quote-quote, model, so that when there is a next project to come, it can benefit when you, for example, you are connecting a new tunnel to an existing tunnel, it can benefit from the description of what has been encountered around the excavation of the first tunnel, to give you an example. And the first thing that we did was to try to get to a consensus, an international consensus, and we got that pretty quickly, whereby we would basically rank or classify information between factual data, interpreted models, and everything that relates to exchange of information between the geotechnician and the civil engineer. Factual data being borehole information, laboratory tests, things of that nature, and then that leads to the creation of a model, a 3D model, thanks to the interpretation of that information. And this 3D model is meant then to help the civil engineer choose the proper path for the underground structure, so given what we feel is the knowledge of the subsoil situation. So this exchange of information between geotechnicians and civil engineers was something that we needed to clearly clarify, because to a large extent, what happens today is that people exchange Excel files. And when you are a civil engineer in a 3D context, trying to understand what the Excel file means in terms of describing what might be the situation before you start digging, that's not easy. So we needed to provide a way by which the result of the interpretation by the geotechnician is clearly understandable by the civil engineer, if you see the relationship in between the two. Right, and in that context, we had to deal with concepts which do not have a physical representation, for example, and of course IFC allows for it. Typically, uncertainties and risks. So you can modelize in IFC and exchange information in IFC that describes those concepts, although they don't have any physical representation per se. And again, IFC allows for this. Thank you. So on this part of the project, as I said, we started clearly to make that assessment together with OGC representatives. So we have OGC representatives in our team, and we have liaisons both ways, and we make sure that at the end we have a common domain conceptual model, so that we make sure that a particular concept, a fault or whatever, is described and understood the same way in between the two worlds. Of course, there are going to be two different implementations, one on the BSI mechanics and the other one on the OGC mechanics. On the OGC mechanics, this is very much the geoscience ML format, and of course on the BSI side, this is the IFC format. Another interesting collaboration that we had started was with the International Society for Soil Mechanics, because there too they have a set of course, experts and affiliates all around the world, and these people likewise got interested into what we had defined because they had started some initiatives on their part, but they could get that we were more advanced, and just the fact that we had defined this together between BSI and DGC led them to adhere and to disseminate the information that these concepts were now commonly defined at an international level. So that was the part on geotechnics as far as the scope is concerned. The other aspect is related to the structural physical objects themselves that are installed, that are cast in place when you realize the tunnel. And the first thing we started to do was to identify spaces, because of course the tunnel on an underground structure is a very constrained environment. So you need to be planning ahead of time. Everything that you need to install, you need to be installing into a tunnel. So first thing we did was to try to identify spaces, whether they result directly from the excavation itself, whether they result from the support technologies that are being, supporting components that are being installed at the time of the excavation, the lining of it, or whether they result from a requirement in terms of being able to install systems. So all those different spaces here, you see them in a lateral way, but there are as well a notion of longitudinal spaces that you need to be guaranteeing, of course, because circulates train or circulates road traffic in these limited spaces. That was the first thing, one of the first things we did. And then when it comes to the structural aspects of things, likewise, we identified basically three main ways of realizing those tunnels. One is through a tunnelier, so that's through a mechanized approach, TBM, tunnel boring machine. Another one is through a conventional approach, which is typically drill and blast. And the last one is more related to prefab structures like cut and covers. And to some extent, by the way, this forms the basis of what we could inject into the IFC for immersed tunnels that the maritime domain is contemplating developing, because there is in some ways this is something that can be derived from that part of our project. So there is a connection like in between two domains. And as far as systems are concerned, of course, we need to be describing ventilation systems and their components, dewatering and drainage, firefighting, safety, and power supply, which are the main components of the different systems that you'll find in an underground structure. With that, I think I should hand over to André, who will be explaining how we leverage this domain expertise.
Yeah, so of course we wanted to develop an IFC extension. So I give you a quick overview about this quite complex process. So on the left-hand side, you see the steps. So they are quite established now in all kinds of extension projects. So first of all, we have done our requirements analysis. This has done together with the domain experts, of course. So we captured their domain knowledge, the requirements, we defined the taxonomy. All that has been done mostly in the form of Excel sheets, because this is something they can deal with. And then we took this as a basis to design the conceptual model. To this end, we used Enterprise Architect, which is an UML modeling tool. And this conceptual model is then the basis for the actual schema extension. And for the schema extension, we use Express and develop all kinds of other representations from that. Of course, this is an iterative process. So we created first a draft, then we validated this draft together with our software vendors, and we are now working on the final schema extension. And when we have done this, then we go and we hope for the formal approval of our developments by the buildingSMART international bodies. So for the actual development process, we made use of GitHub quite extensively. So this is an open source repository, so everyone can really access it. You can scan this barcode here and directly access the website. The GitHub has all the developments that we are proposing, like really the schema extension itself. It's completely open. Everyone is invited to participate and comment on our developments, but of course we are now coming to an end. But nevertheless, you're still very much invited to have a look into our developments. From this repository, we create not only the Express extension, but also the HTML documentation, which is of course much easier to digest for programmers and for the general public. So again, we have a QR code here. Again, you're invited to scan it and have a look on the documentation. The documentation is really comprehensive. It includes all the developments again. So you have the chance to also look into the change log, seeing exactly what has been proposed, where we have new entities and so on. The new entities, of course, are included also in the documentation. You see precisely what superclasses they have. You see also the documentation, so all the entities are documented in the way IFC is documented, and also the predefined types and so on and so forth. Here you see one example. So this is the spatial zone type enum, so something quite special, but we need it in tunneling. So we have created extensions here. Spatial zone type enum existed before, but now we have new predefined types, namely annular gap, as you see it here, or invert, lining, and service. So these are the new predefined types that we have defined here. And this is only one example out of more or less hundreds of new elements that have been defined. So this is again for Michel, so the involvement of the software vendors into the testing process.
Yes, because we wanted to have the software vendors sort of double check what we had proposed in terms of specifications for those new concepts. Of course, given the capacity of their existing software packages, right? And to some extent, the IFC model, when it comes to those disciplines, may be a little bit richer than their own software solutions conceptual model. So that may require to some extent that they extend a bit their own software conceptual model. That's okay, because this is something we can help them with as well. The important thing is that everyone understands that we are serving an industry, and they can serve an industry whatever the positioning of their own solution is. And to that extent, we have software vendors who provide solutions for helping with the interpretation of geotechnical data, the creation of interpreted models. That's one side. We have software solutions who typically deal with excavation and civil works, and others who typically deal with systems. So that was important. We have this coverage. Number two, we have people as well who deal directly with machine guidance. We wanted to make sure that that part of exporting information from a model, a BIM model, can be done in a rich way so that the machine itself can be directly guided by data extracted from the model. And to a large extent, today, most of that happens through CSV file, Excel files, doc files, and that is, of course, a bit of a nightmare. So we needed to get the provider of machines to integrate IFC as a mean to export data straight onto the machines. And when I mean machine, I mean a tunnel boring machine or any other kind of excavation machine. As-built capture as well, as-built recollection was another one. And of course, we have as well collaboration with those who provide BIM collaboration platforms, IFC Checker, to some extent with assets management, because they are likewise, we want to make sure that those who build assets management system understand the value of extracting data from an IFC model. The part of the information in an IFC model that is relevant for assets management, right? And so we have some software vendors that are in that space, and we have as well 3 providers of libraries toolkits which typically, the big software vendors would be reusing, like the Autodesk, the Bentley, and the Trimble of the world. So you cannot see the list exactly of those software vendors, but we have, for example, of course, we have AK Software. We have, I mentioned Autodesk before. We have Beaver Control, who is a provider of machine. We have Katenda. We have 12D in Australia. We have our friends from Audio here in the room with a specialization on geotechnics and seismics. And the Trimble team as well at different level. So an interesting mix. And the way we took those software vendors by the end to create proper IFC exchange files was by going through sprints, which are basically a set of concepts that you need to be implementing in your software when creating an IFC file. So one by one, concept by concept, we needed to make sure that they all understand, and I should say they all understand the same way, because it's one thing to do the right thing, it's another thing to be making sure that everyone does it the same way. So it's more about commonly understanding the same way of doing things as opposed to the most dogmatic way of doing things. Yep, if you can, I think there is another slide.
Yeah, this is really important. So the deployment, as we call it, is a really integral part of the entire project. Because developing a standard, then later it comes out that it's not usable, that would be not good. So this is now in all the extension projects that we, as early as possible, involve also those that in the end should implement the standard to make sure that it is really a good standard. So this deployment project started a year ago, or actually at the beginning of 23. It's still running, but it's coming to an end. And Michel said this already. Here on the left-hand side, you see the individual sprints. For each sprint, we had a couple of weeks. We gave the software vendors a task to implement a certain concept, like, for example, the spatial structure of tunnels and other aspects. And then we checked if they have done it correctly. And of course, they also had feedback with respect to the data structures, the documentation, and so on. And this feedback was super helpful because then we could integrate it into our development process. So they created issues and pull requests directly in our repository. So this was a really, and still is, a very important interactive phase where we bring in the software vendors really early into the standardization process. We now come to a topic that is a little bit complex because we are actually dealing with the issue of synchronization or reconciliation, as we call it, because we are working on the baseline of IFC 4.3, but IFC 4.3 has been continuously refined while we are working on the tunneling extensions. So essentially, we have two different repositories. On the left-hand side, this is the official buildingSMART repository with the latest developments in IFC 4.3. And this is our repository where we do our very dynamic developments in the area of tunneling. So what we have to do is we have to take over all the changes in the IFC 4.3 repository to make sure that in the end we have really the same baseline and build up our extension on the latest release of IFC 4.3. So in the moment we speak about IFC 4.3 Addendum 2, this is kind of the latest version of the official IFC standard. So here it's said again, so the baseline for IFC tunneling is 4.3 Addendum 2, so the official ISO release. We have still a number of issues open from the ISO process. So during the ISO process, and some here might notice, there was an iteration necessary. So ISO identified 575 issues with IFC 4.3. They had to be cleaned before ISO could adopt really the standard, but not all of them have been resolved. There are still 145 issues open on IFC 4.3. So we kind of inherited these issues and are still working on them and are also proposing solutions to these issues that are still open. Of course, the main scope of our project is the tunnel-specific concept. So this is where we actually put the most effort into it. And what we have taken out is the immersed tunnel concepts, because this is now in the new maritime project. When we are done, and this will be, well, in Q2 this year, then it will be adopted by buildingSMART. And then, of course, we also hope to get the ISO stamp. So our developments go into IFC 4.4, and then IFC 4.4 will also go to the ISO standardization. And of course, we will help in this process and support this process as best as possible. This is, again, important. So this is the timeline. We have started already in 2019, so it's a long project, but you have seen the scope is also quite large, and we have a certain complexity here. And of course, we want to have a good standard, a stable standard. This is why it also takes some time. So we first have developed the requirements analysis. As I said, the report was published in 2020. And then we have worked on this conceptual model, which is an UML model that has been published as a PDF. Then we started the schema development. Early draft was already published end of 22. And then we started the very important deployment phase, where we worked, as I explained, intensively with the software vendors. So this is now coming to an end. Also, the schema development is coming to an end. And in Q2 this year, we will then deliver our final proposal for the extensions. And then this goes into approval by the formal bodies of buildingSMART, and this will then be integrated in IFC 4.4, which is then taken to ISO. When we speak about ending the project, and we have to deliver something, of course, and we make use of the buildingSMART process guidelines in this respect. So we follow them, we implement them. Latest version is version 7. So this is the version we are referring to here. This includes then the requirements analysis report. This includes also the conceptual model. So we hand over our enterprise architect model. We also have a report created from this model, a PDF, essentially. We also create the change logs, like what exactly we are proposing to change and extend. And we also, and this is the most important part, we have the actual schema extensions being defined in Express. So this is the formal definition language of IFC, and we make use of this as well. This includes then also concept templates, usages, and property sets. So the property sets are really big. It's a lot of work that we have invested there. So this is really a big part also of our deliverable. This will be done in XML then. And of course, documentation and a number of other things that I would not go in detail here. And well, this is also important. Then, of course, we have to integrate our developments back into the main repository. Luckily, Thomas Kreinen, who is handling the main repository, is in our team, so he will help us to do this final step, then integrating our extensions into the official buildingSMART repository. And with this, I think we can hand over.
Thank you, André. But I know that there is a burning question that you are asking yourselves and do not dare asking us, is how do you intend to inject that information into BSDD, for example? And I think that from what we've now started to understand on what this proposal on behalf of BSI is capable of doing, I think that's one of the things that we will be probably doing next, is grab all this intelligence, this domain expertise that we have today in the model and in the different taxonomies, and have that injected into BSDD as a sort of an international reference data dictionary. That's probably one of the steps that will be carried on in the coming weeks.
Now we hand over to Lars.
Now we do, yes. So because you don't have enough of technicalities as to exactly what this project is about, now we are really getting technical. That was the easy part. Now that's more of the complex part.
Okay, so we've got Lars just joining us. If you want to say hi to him, Michel. I'm going to switch over to Lars's slides while you're just welcoming him to the call.
So Lars, you can hear us?
Yes, I can hear you, and I think we would like to present ourselves. It's me, Sergei, and Stefan.
Please do so.
Okay, thank you. Yeah, so it's me, Sergei, and Stefan, who is also together with Andre in the technical team, and there will be some slight repetition here, but we'll try to go into a little bit more of the technical detail, and then also demo some work that is typical that we are doing now in the deployment process of our project. Yeah, and we'll switch a little bit. So I will take some parts, Sergei will take some parts, and Stefan will take some parts. So we'll switch among each other as well. So I hope you hear me okay.
Yes.
Yep, perfect.
Go ahead, please.
Yep.
Yeah, go ahead.
So,
Yeah.
yep, thank you. A little bit repetition regarding the process that we have been working with in the technical team then. So you have heard that we have the IFC tunnel requirements analysis report. We have the 3 different domain expert groups that provided us with their taxonomies, sort of using their own vocabularies, of course. And we also have already from the IFC infra and rail projects, we had modeling guidelines for UML, conceptual modeling then. And based on this, we have done UML modeling in Enterprise Architect with these the requirements analysis, taxonomies, and modeling guidelines as our input. And based on that, we could also then generate a couple of reports. I can show you an example, and also create the IFC for tunneling extension that Sergei will show you a little bit more about a little bit later. And as Andre mentioned, we also have to take care of this reconciliation with the IFC 4.3 add to baseline. And I mean, we started quite long before the ISO submission process and so occurred. So we have some work to do in that area as well. And then we are now in the middle of this, or maybe at the end of this deployment process. And you see the arrow goes both ways there. It's a way to involve the software vendors in sort of understanding and looking at what we have produced as far as the IFC extension goes. And it's also, of course, goes the other way. It's a way for us to test that we have produced, what we have produced actually works. So things can happen, changes can occur in the schema during this process. And as Michel mentioned, we have the 3 domain expert teams, geotechnics with the factual, interpreted, and design-related data. We have excavation, support and lining team with also different, couple of different subdomains: excavation, ground improvement, waterproofing, pre-support, support, lining, and interior. And we have the systems with things like earthing, firefighting, drainage, power supply, safety, and ventilation. And Michel wanted me to just do a short demo of what we do in the conceptual modeling phase. So I'll bring in, I hope you see it. You should now see Enterprise Architect here. Can you confirm?
Yes.
Yeah, we can see.
Yeah, good. So we actually work in exactly the same way as was done in the previous infra and rail projects. We added a piece here for IFC tunneling, and you can say that this is done actually in 2 steps. First of all, we take care of the taxonomies from our domain expert teams, such as geotechnics, for example. And as you see, the UML model is sort of structured. You would compare it almost with the structuring of an IFC file with its spatial structure and system structures. So it's a hierarchical breakdown of the model. So here we have geotechnics with the book A, B, and C. And in here, we start with adding the taxonomy from the domain experts with their vocabularies and their definitions. And based on that, we then work with mapping that either to stuff that already exists in IFC, or if nothing exists since earlier, we need to add new concepts such as new entities or new predefined types to existing entities and so on. And when we have done this work, we can actually then generate reports, and I'll just quickly show you an example how such a report looks. It's a document with some introductory text and some basic explanations on how IFC works with spatial breakdowns and functional breakdowns and component breakdowns and so on. And then it's practically a listing of what's in the UML model with diagrams, definitions, properties, and things like that. So the reports shows the domain taxonomies in UML. They show the mappings to the proposed IFC for tunneling extension, including the complete IFC extension, but in UML form then. And it shows what we actually reused from before, and it shows all the new definitions. And we have 5 reports, 1 per sort of a domain expert group. So 1 report for systems, 1 for excavation support and lining, and 1 for geotechnics. We have 1 report which covers the entire IFC extension, and then we also have a reading guide for those of you who are not so familiar with UML notation and so on, so you can perhaps understand a little bit better what the diagrams tell you. And with that, I think I will leave the floor to Sergei then.
Perfect. So with this slide, I would like to just start the reference back to the introduction. Like when we are working, we are using this process. Of course, we are in constant exchange with the domain experts, and we're constantly redeveloping the schema, we're constantly updating, and in the deployment process, of course, we're also then constantly reapproving and checking the files. Domain experts, for example, just now were involved a lot with properties, which is a huge task, and when thinking about properties, we actually had to adjust the elements a lot, introduce new predefined types, remove certain predefined types that we introduced before, because the concepts started changing when there was more thought put into the definitions. And of course, in this process, every time we produce a new schema, we also produce a new toolkit that is used for the checker, which checks the files that the software vendors deliver. And we have these workflows set up that allow us to have a constantly updated a constantly updated platform for development and deployment. So with this, I would like to say goodbye to the slides a bit. I hope you don't mind. I think you had just about enough slides in the last 3 days. So let's go to what we actually produce. We are using this repository. Again, it's public. You have the QR code for scanning. You can access this whenever you want. It's also public to clone and download. You can also view it with our tooling at any point in time, or you can directly just go and type IFC tunnel in here and find the tunnel related. Oh, sorry, I should have actually went to the tunnel branch. So always when you want to review tunnel stuff, you have to go to the tunnel branch, and you can then type in your tunnel specific concepts and just search for the definitions. Andre before showed the two parallel branches that are being worked on in our process. One of them being tunnel, the other one develop. So the develop branch is where we merge in all developments from the 4.3 addendum 2. We just now produced a diff, and we're introducing those developments again in. This branch serves as our default main branch, and all of the developments from addendum 2 are then merged directly into tunnel. They are kept in sync so that we have the same baseline, or at least as best as possible of a baseline to work on the tunnel developments. The process pretty much just gathers the requirements and change requests and feedback in this issues tab, where we try to tag them appropriately, put them into our tunnel project, and track them. And this process is then tracked with this Kanban board that you can find under projects. You see we have a very long backlog that we have to-dos in. We also try to tag the issues so that it's clear which issues are addendum 2 issues, which issues are tunnel issues, and then these issues in the process are mapped to pull requests, where we actually work on very granular concepts. I can show you one of the issues, for example, here. This is a tunnel specific issue, or let's say pull request, where we have we had a request to split improved ground grouted into injection grouted and jet grouted. So a predefined type was split into two. This kind of a pull request, but it was then worked on. It was implemented. You can see which files and the specification changed. You can see also the documentation that has been added here, and you can see the constants that have been added. And all of this is then tracked very granularly in this huge specification that we have. In the review process, approval is granted, and when the approval is granted, these changes are then merged into our either tunnel or develop branch. So this is a tunnel specific thing, but we also have reconciliation marked pull requests, where we are adding the changes from the official repository again back into our repository. And as you can see, we find issues, we find typos, we find problems with the schema, which we then try to post also back to the official repository. Here we have the dilation track and dilatation sort of discrepancy in the documentation, and again, we track this and try to also produce change requests in the official repository. You can also, so all of this progress is our pull requests, which are linked to issues, which are then automatically closed when things are done. and go into this final bucket, which is also quite substantial, quite long, as you can see. From this, we have a couple of workflows set up that generate our schema for tunnel, the schema for addendum 2, and also property and quantities specifications every time a property is changed. This kind of a workflow will be generated, where you can then download the properties and quantities XMLs. Every time tunnel schema is changed, you can download the new tunnel schema. This is how also our software vendors keep up to date with the latest developments. Every time the baseline, so 4.3 is changed, a schema generation is documented, and you can download the IFC schema from here. There are some filters for our workflows where you can just click and filter all of the workflows that have been run for a particular task. So documentation generation is one, filter changes, schema generation tunnel, all of the tunnel schema generations, all of the schema generations, all of the property and quantities listings, pretty much. So this is how it works. Once we come to a expert panel, we also regenerate the documentation, or we try to regenerate it as much as possible. This is then generated into this repository, IFC documentation tunnel, which is also automatically deployed into this website. Here, I just wanted to show you the IFC 4x3 to 4x4 changelog, which is found under change logs. Here, F13, this is our changelog, which is divided into entities. In entities, Michel already explained, we have changes to kernel, to product extension, to all of these sub-schemas that the entire schema benefits of. And we also have changes, of course, to the tunnel domain, where it is very specific to the tunnel developments. Going further to properties, we also introduced already a lot of geoscience properties. We are now also working on lining and support properties and so on system properties. These are then listed in the properties link. Quantities, we have not introduced many here, but we do have for excavation, for example. And in model views, also what we introduced in terms of updates to the usages of the entities, because in the process of in the deployment process, we also have to introduce usages, so how to actually use an IFC tunnel entity, and all of those are then listed here in the model views tab. So with this, I would hand over to Stefan.
Thank you, Sergei. Very good, as always. I'm going to bring you into the feed then, Stefan.
Hello to everyone online and in Valencia. Stefan Jaud, my name, and I'm going to show you quickly how the engagement with the software vendors looks like even. So Sergei has presented quite in depth what the changes were, how to navigate from one to the other, what has been changed, what has been improved upon. And as part of the deployment, we have been active with the software vendors themselves. And for them, we've established another repository. So this is an IFC tunnel deployment repository, where we have prepared a few different sprints and a few different, let's say, requirements for the software vendors to try their implementations out and see how far they come, and if, of course, the standard itself that we are developing is implementable. And as Michel has already told you about the book A, book B, book C type of things, we have come up with an example for all of these books. And for example, for a book A, we've requested software vendors that are interested in that part of the schema to please produce an IFC file that has an IFC borehole in it. It should be contained in IFC site. It should have some geometry, should have some local placement, some properties attached to it. Then we've also asked them, for example, a new addition to the schema is an IFC geoscience observation with a predefined type borehole log. And here, of course, the software vendor was requested to attach this to this borehole defined in point number 1. And we had quite an interesting exchange recently with one of the implementers where he wanted to make multiple observation logs on the same borehole. This wasn't foreseen previously, but as it turned out, it's a completely valid case. So we have been now playing around a bit as how this goes. Is it the geoscience observation that is composed into different observations? Is it a borehole that is linked to different observations? How this whole property sets, to which of those do the property set get attached to, and so on and so forth. And as such, we have been really fine-tuning the requirements, which represent the basis then for example, software certification, if at some point we get that far. For this, for example, so I'm going to now jump on exactly this requirement. So please keep this in mind that IFC geoscience observation borehole log should have some properties attached. Let's go to an IFC file submitted by one of our participants, that is the Oyo Corporation. So here you can see that the participants have opened pull request, have submitted IFC files to be checked, and there's a very, very short description of what can be expected in such a file. We're trying to keep things very informal and very on a short and bullet point type of art. So here the Oyo Corporation said, hey, I have a file here that's containing some voxels. We have had some back and forth. Hey, we looked at the file. Here, perhaps you want to improve on this one topic, or perhaps you want to fix this one thing. You can see it's quite active. This is now from a month ago about, hey, please correct, for example, here you have a wrong encoding within the file itself. And now at the end, if we look at one of the actions where the file is not yet completely in line with all the requirements that we're having, but then again, it lets at least see if these borehole things are fine. And as you can see, for example, on this IFC geoscience observation, we've said there should be this log attached, and this log should be assigned to a borehole. Well, there are some observation logs that were not attached correctly, or not attached as we have envisioned it. We still need to double check, if the file is still semantically correct and just the checker doesn't do its job correctly. But then again, of course, there are some other issues that perhaps need to be addressed before we accept such a file, or perhaps we're just going to oversee them because the requirements themselves are, of course, made up just for the sake of, presenting an example of how it can be done. And the software vendor can, of course, decide to knowingly neglect these. So I'm not sure if there's a representative of Oyo. I'm really happy about this file. It's of very high quality already. And also being very, very active on this whole checking procedure. You can see that there have been multiple submissions on a single day where apparently the developer was trying out and trying to fix his things. As it currently stands, we still have some files that we need to look at, so the technical team of the project. We are also encouraging still all the participants and also those that have not participated yet to join and submit a file, see how well it is, how well conformant it is to the schema. And of course, as well, if you find an issue, I think Lars is now going to take over presenting you a schematic of this borehole issue that we've encountered. If you found an issue with the whole specification, please do come forward. Now is the best time to still influence how the standard looks like. And with that, I would pass over to Lars to show you just a schematic or two in the PowerPoint that we've prepared.
So just once, whilst you are uploading, so this environment is one of the things that we provide the software vendors So to help them, we've been providing as well example files so that they can copy paste basically the code that concerns that one concept into their own code. So that simplifies, of course, the implementation on their part. And we provide 2 support calls per week where they can connect and get directly in contact with us, and then we can go through their code and help them make sure that they've implemented the proper way or just as need be. So that's really an ongoing exchange with the software vendors at a rather steady pace, I'd say, and I believe that everyone appreciates this.
Stefan's sharing the slides.
On the screen, you can see right now the borehole in the middle, and there were 2 tests performed on this borehole. Test A on the left-hand side in blue, test B on the right-hand side in red, and they've produced different results from different sections of this borehole. And as such, of course, we would like to present both results within the same file. And for that, we need 2 geoscience observations.
Stefan.
Oh, Sergei's here. Yes?
Yeah, sorry for interrupting, but nobody was looking at the private chat where we agreed that I take this over with Lars before that, because I have everything open already with the file and so on. Sorry
please
for that.
do so, yes.
Yeah,
no worries.
Sorry for that.
Please do so.
Okay, do you want to take it then, Sergei?
Yeah, I will share the screen.
Okay.
So, like Stefan already started, we had this issue with boreholes where a separate requirement came in that observations might not be a one-to-one relationship with the borehole itself, and it might be that there's many results per borehole. And as you see here in this sketch, we have 2 results with a borehole separated into sections, which have different lab results attached to them in terms of p-sets. And for that, this was, like Stefan mentioned before, this was never actually envisaged before, but it was a clear requirement. And from this, that's why we also had these many iterations with the borehole files. Not only that, but schema was also a problem. We sort of came to a conclusion here that we have created this kind of a file where geoscience observations are geometrically linked to a borehole and as a line. You can see this line here as this green line. And this is then linked to a borehole with 2 different geoscience observations, which have different breakdowns, so different lengths of measurements, and they have these p-sets with the results attached to them. The second part, of course, is the other measurement, so test B, with the same sort of a structure, but different measurements, obviously. Let me actually skip here to the live file. We have this borehole that you've seen before, and we have geoscience observations attached to it. It's hardly visible, but I hope that this green line in between here is visible. And this is then, these have then the properties, the actual measurements attached. So now let's get back to our presentation here. The funny thing with this is we are using all kinds of methods to produce these files, and one of them is a completely manual writing of files. Others is through toolkits. The third one is to modify existing files. So we do all kinds of tricks and so on. And for example, here we have the voxel grid example of from Oyo, Japan. Again, this was a this was an exercise of how to actually represent voxels in an IFC file, because this is one of our resources or one of our added resource entities, so that we introduced a new type of geometric representation that can have data attached through a direct linking of indices, which makes it very efficient and also makes it very useful for geoscience, where each small individual voxel can have its own data value attached to it. And now let me maybe switch over to our other type of, or let's click through this one first, just to give you an idea how this works. To a certain spatial zone, we can attach a geoscience observation. This geoscience observation has certain properties attached to it, but the most important thing that we see here is that the geoscience observation shares its product definition with an entity, IFC real voxel data, and both of them reference the same voxel grid, where IFC real voxel data by index, like I said before, attaches values of numeric values of measurements, and this is the actual result, as you see, for this kind of a representation. The funny thing, of course, is existing IFC viewers don't support that yet, obviously. So this visualization here comes from other sources. And the other, let's say, very nice mechanism that we used is, and also thanks to the French tunnel authorities, is a conversion-based mechanism where we produced a complete IFC 4.4 data set on existing data. The original file is 4.1, although let me actually show you here how the file looks like. So the original file has this very basic structure. It has a decomposition into many building element proxies. You see, it's just a long list. Not all are listed here, but it's a huge list of building element proxies inside a building. What we did here is we just read in this file, and that's why it's so good that we have a constant development of or a parallel development, that the toolkit is automatically generated from the schema, because we can then, first of all, compile the schema, check quality of our developments, but also check existing files and also produce new files. So what we did here is we took this long list of building element proxies and produced something like this. We produced the first IFC tunnel in a complete data set, let's put it like that. Has the same name, obviously, but it also has a tunnel part breakdown. So here, for example, we didn't yet have a proper idea of what to map it to. So the tunnel parts here are still building element proxies. But if we look at the section part, we have many assemblies, coverings, ground reinforcement elements, and so on. So just as an overview, but now let me show you something else. We have also a visualization of this file. Let's open this up a bit. Where, for example, not only did we create a spatial structure, we also created something like a waterproofing system. And let's see how this looks like. Let's just see. This is our waterproofing system, which is compiled from many IFC covering elements. Let's just check one, which has a predefined type membrane. And then we have also another tunnel-specific system. This one was waterproofing. We have another tunnel-specific system. Okay, maybe this one is not tunnel-specific, but we introduced it in IFC tunnel. The other system that we have is actually very tunnel-specific. It's tunnel pre-support. I find this quite interesting because it's a system of elements that's sort of very specific to pre-supporting to the pre-supporting concept. And if we look in it, we can see that the tunnel pre-support has an element assembly attached to it, which has, or many element assemblies attached to it. This element assembly has a predefined type, again, a tunnel predefined type pre-support vault. And it also has certain ground reinforcement elements attached to it. And these ground reinforcement elements are, again, something new. They are of type bar. And we have a very nice structure that we can use to manage and compile this. One thing I haven't showed yet is also that we have arch elements in our data set. So let's click one of our arch elements. This is a pre-support vault type element assembly. And these arch elements inside are of type user-defined support, which is a requirement that also came from our domain, as a matter of fact. And this is just now in the pipeline to merge into the existing specification, because we weren't sure how to which criteria to use to produce these predefined types. So we only had user-defined, not defined lining and support predefined types for arch elements. But now there was a requirement for support, but it's not yet merged, so you don't see it in here. We have to use a user-defined predefined type. Let me show you one that is in. Let's open this one. So this one is another pre-support vault that's compiled of arch elements, but these arch elements are of type lining. And as you see, this predefined type is already in the schema and it's already visualized properly. I could also guide you now back to GitHub, where I can show you about the support request. I mean, the predefined type support request that you can that's supposed to make it into the schema. And once it's done, of course, the checker, the files, and everything else shall be updated. And one final thing, how do we track this? Let me show you this. This is the original file on the left. So you see 4.1, and this is the 4.4. This one has only one owner history. It has been produced by Autodesk Civil 3D by Villanova. So really nice tracking. But now let's see what else we can do with owner history. Again, owner history of the original Autodesk Civil 3D Villanova, but then we introduced new elements, or this is the owner history that modified existing elements, and you can see all of the arch elements were modified, building element proxies, coverings were modified. It was produced by the tunnel team. And we also have some additions from the tunnel side, where you can see that we actually introduced completely new entities. So we aggregated a bunch of stuff, but the most interesting are the element assemblies pre-support vaults. And you can see these elements have been added again by the same entity, by the tunnel team. And let's see if there's any. Oh, of course, tunnel parts and the systems were also added for filtering possibilities. And with this, let's just jump quickly back. Thank you very much for your attention. Here you can see our contact information. So, you know, if you're interested in anything, you can get a hold of us.
Thank you, Sergei.
Yeah, thank you very much, gentlemen. Thanks, Lars. Thanks, Sergei. Thanks, Stefan. Thanks a lot. So I was making a promise to you when I started that we would have examples ready for you to double check. So promise is there. Thank you again. I have two comments I'd like to make. Maybe first, Sergei, can you jump back for me on this slide you had with the voxel? So I'd like to relate this image to what I was saying earlier on in terms of this is the result of an interpretation done by a geotechnician expert. A civil engineer is using this to optimize the path of the tunnel where he understands, where he can read that this is the least risky option to take. So he doesn't know, he doesn't have to understand how the interpretation has been made. What he needs to be providing with is an easy picture of the probable situation for him to design the tunnel properly. So this is this exchange that we are trying to make sure we help and we have people communicate together. Just to give you a sense as well of the nature of the debates that we've been having with the domain experts. So typically in the construction world, you would deal with things that are built. So man built a building, a road, a railway. And then you have existing natural situations, subsoil. So we talked about earlier on as to whether we know the subsoil or no, we believe what the subsoil might be, and so on and so on. So it's an easy split, either natural stuff or as-built stuff. But when you deal with underground projects, you do as well reinforcement of the subsoil. So you take portion of the subsoil, you reinforce it with cement or concrete or whatever. So what is this? Is this a natural thing or is this an as-built thing? When you inject cement in a fault, what is this? Is this a natural component or is it an as-built component? So we needed to be having those discussions to try to rank things properly when it comes to the different concepts that we were. I thought that was an interesting thing because we sort of introduced a third nature of what it is that we are facing. The last comment I'd like to simply make is that it is, of course, extremely positive to see things converging at the stage we are at, because we're starting by, of course, making an analysis of what it is that we should be trying to cover. That was, we were, widening and widening and widening and widening, and now we start to converge, and get back to things that are practical to implement. And I think we've gone there, and with the examples that we'll be expanding, providing, I think it's proving the value of what has been done over the past 3.5 years. I'd like to, again, special thanks to Oyo Corporation for the involvement and the production of those real-world project data, and the Ministry of Transportation France as well for having been, pushing and making sure that those examples can be distributed to anyone in the world. So with that, I think we are concluding our presentation. Andre, do you want to add anything, or maybe asking for questions?
Yes, indeed. So now it's time for questions. We know it was a long session already, but we have 3 minutes left for questions.
We have 2 or 3 minutes. If there's any burning comments or questions in the room, now's your chance.
Everyone is exhausted by the material.
Then I have one question. Have we exceeded your expectations?
I think you have, Michel.
Okay, thank you.
You have. Thank you.
Thanks for your attention.
Just want to say thank you to Michel, Andre, Lars, Stefan, and Sergei. Excellent presentation. The project's made great progress. We're all looking forward to the final set of deliverables, which you're tantalizing us with by showing us some of them. I can see they're well underway in terms of the reports and the technical information in GitHub. So that's really good. Thanks very much, guys.